Alright, this is Chapter 5, homework number 1, starting with 5-6. What if the data for Linny and George, from this problem in class, match the data in each table below? Assuming that the growth of the rabbits multiplies, as it did in problem 5.1, complete each of the following tables. Show your thinking, or give a brief explanation of how you know what the missing entries are. I'll do B. So as discussed in class, we need to figure out how this is growing, and it grows by multiplying a constant number. For example, times 3 times 3 times 3. We don't really know. Okay, so let's start with the easy one, 2. Let's say this grows by multiplication by 2. Okay, so 6 times 2 is 12. And let's see if that matches. 12 times 2 is 24. Okay, that matches the table. 24 times 2. That's 48. And 48 times 2. 2 times 8 is 16. Carry the 1. That's 96. So that's a match. So it grows by multiplication by 2. And there is my table. It says to show your thinking, and there's me showing my thinking with the little arrows and the times by 2 symbol. Okay, so try that for A. 5-7. The equation of a line describes the relationship between the x and the y coordinates of the points on the line. Plot the points 3, -1, 3, -2, and 3, 4. Alright, draw the line that passes through them. State the coordinates of 2 more points on the line. Okay, so there's my line that passes through all of those points. That didn't really work out. Okay, so here's a point on the line. That is going to be 3, -5. And then here's another point on the line. That's going to be 3, 0. Alright, then we write an equation for the line. So this line passes through the x-axis at the number 3. So the equation is x equals 3. And that is the equation for a vertical line. When you have a vertical line, your equation is x equals a number. X equals a number. And the number that you fill in the equation is wherever your line is going to hit the x-axis. So it hits the x-axis at 3. Equation is x equals 3. Alright. Part B. Plot the points 5, -1. 1, -1. -3, -1. Over to the left 3 and down 1. Okay, if I draw a line through there, what is the equation of that line? Well, this is a horizontal line. Remember that for a horizontal line, the equation in general form is y equals number. Okay, this is our y-axis. Our line is going to hit the y-axis right here, and that is at -1. So the equation is y equals -1. It hits the y-axis at -1. And then I'll let you do C, so I did A and B there. 5-8. What number is not part of the domain of the function x plus 2, g of x equals x plus 2 divided by x minus 1. So recall that you can't divide by 0. So on the bottom, that can't be 0. So what number could you put in that would turn it to 0? Let's try x equals 1. So it's 1 plus 2, plugging in 1 for x, 1 plus 2 over 1 minus 1. And that is 3 divided by 0. That doesn't work. So what does that mean? We can't input 1. Alright, also remember, domain by definition is the list of all possible inputs to a function. Okay, so let's look at this function. We can't input 1, and that's the only number we can't input. So for the domain, we can input any real number except x equals 1, right? So we can input any real number except x equals 1. How can you tell? You can't divide by 0. When you plug in 1, it causes you to divide by 0 because 1 minus 1 is 0 and 3 divided by 0 is undefined. That's not allowed. So we can input any number we want except for 1. That's the domain. The domain is the list of all possible inputs to a function. 5-10. Plot triangle ABC on graph paper with points A, 1, 1, B, -1, -1. Oops, that's -1, -1. So B is down here, left 1, down 1, -1, -1. And then C is 4, -1. So there's our triangle. And then let's look at our transformation. Use the function x goes to -x, y goes to y to transform triangle ABC. Label this triangle A prime, B prime, C prime. What kind of transformation does this produce? And name the coordinates of the image below. So let's look what happens to the x coordinates. If we start with x, then we end with -x. So this is basically saying to switch sign of x. For example, if our x coordinate is 1, like it is here, then after the transformation, it'll be -1. If our x coordinate starts as -1, then after transformation, it'll be 1. So you just switch the sign. Negative to positive, positive to negative. So for the last one, the x coordinate is 4, now it's -4. So think about the middle one. If you have -1 as an x coordinate, and then you drop a negative sign in front of that, that's basically what this is saying. Put a negative sign in front of your coordinate. Now you have -1. So -1 is +1. That's the y. That's why this is 1. Okay, let's look what happens to the y coordinates. Y goes to y, so nothing happens, no sign change. Y stays same. So here our y coordinate is 1. After transformation, it's still 1. If the y coordinate is -1, after transformation, still -1. -1, -1. So all the y coordinates just keep the same. So let's graph this with green and see what this looks like on the graph. A prime is -1, 1. B prime is 1, -1. And so already it's kind of looking like a reflection across the y-axis, right? A prime is a mirror image of A, B prime is a mirror image of B, and then let's look at C. C prime is -4, comma, -1. And sure enough, that is a mirror image over the y-axis. So, what kind of transformation does this produce? Reflection of triangle ABC over the y-axis. Or I think in class I said across the y-axis. It's the same thing, over or across the y-axis. So they're mirror images of each other. Alright, you can try B. Let's look at 5-12. Jill is studying a strange bacterium. When she first looks at the bacteria, there are 1,000 cells in her ample. That should say sample. Whoops, so that's sample. The next day there are 2,000 cells. Intrigued, she comes back the next day to find out there are 4,000 cells. Should the graph of this situation be linear or curved? Well, from day 1 to day 2, alright, it adds 1,000 cells. And then after that, we go from 2,000 to 4,000, so it adds 2,000 cells. Alright, so there's no constant addition pattern, so the addition is out. Well, let's think about it as doubling. It doubles, right? So 1,000 to 2,000, that's times 2. 2,000 times 2 is 4,000. So it's curved because it doubles. And we'll see that in a minute on the graph. Okay, so when she first looks at the bacteria, that's going to be day 0, the starting value. And the starting value here is 1,000. The next day, day 1, we have 2,000. The next day, that's day 2, there are 4,000. So find day 3 and 4. Notice the pattern is it doubles every day or multiplies by 2. Okay, and if we put it on the graph, day 0 is filled in for us. Day 0, there are 1,000 cells. Day 1, we have 2,000. Day 2, there are 4,000. So as you can see, it's not a straight line. It curves because we have double. So part C, give a complete description of this graph of the situation as you did in 5.4. Check your notes. One I'll give you is that it is increasing, right? The numbers are getting bigger. The graph is going up from left to right, so it is increasing. On to 5-13. Look at part D, because we didn't really do scientific notation, and then B. Okay, so for B, we're dividing. It's the same base, so when you divide two numbers of the same base, the exponents are going to subtract. It's that easy. So you just subtract the exponents. So this is 3 raised to the power. 300 minus 250 is just 50. So that's 3 to the power of 51. 300 minus 249 is 51. Let's double check that real quick. This is 9, 10. So this is 10 minus 9 is 1. 9 minus 4 is 5. 2 minus 2 is 0. So 51. Check. Alright, part D. Alright, when you square something, it causes multiplication of that something. So we'll consider this our base. So it causes multiplication of itself 2 times, raised to the power 2. So multiplied by itself 2 times. So we have 4 times 10 to the power 3 times 4. Well, we can actually just kind of do 4 times 4. It doesn't matter what order we multiply these in. And 4 times 4 is 16. Okay, now remember that when you multiply two terms together that have the same base, their exponents are going to add. So this is just 16 times 10 to the power 3 times 10 to the power 3 is 10 to the power, add the exponents, that's 6. And on the bottom, same deal. This is 10 to the power. If we add the exponents, that's negative 2. I'm sorry, negative 4. Negative 2 plus negative 2 is negative 4. Alright, now, if we combine these together, kind of like we did here, if you divide two terms of the same base, the exponents are going to subtract. So this is 16 times 10 to the power 6 subtract negative 4. Now be careful here, it's 6 subtract negative 4. So because the negative's on the bottom, it becomes a plus, a double negative. So this is 16 times 10 to the power 10. Alright? So this is basically 16 followed by 10 zeros. If you want to put the decimal right here, which you can work backwards and count. It should be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if you want to write it in scientific notation, this number right here has to be between 1 to 10. So we move the decimal to the left 1 and then add 1 to the exponent. Alright, so our answer for part D is 1.6 times 10 to the power 11. Or, if you like, just 16 to the power, or 16 times 10 to the power 10. Alexa, we're working on homework together when Jackie said, I got x equals 5 as a solution, but it looks like you got something different. Which solution is right? I think you made a mistake, said Alexa. Let's help Jackie figure out what mistake she made. Explain her mistake and then solve the equation correctly. Jackie's work is to the right. So let's see, we started with this. Jackie decided to square each term, so that's x squared plus 4 squared is 16 minus 2x minus 5, and then that's x squared minus 1 squared, so that's x squared, and then I think negative 1 squared is positive, so plus 1, and that's a mistake. Alright, and this is the fake news mistake from class. Fake news. These two things are not equal. So she should have rewritten and drawn the box. For example, x plus 4 squared is equal to x plus 4 times x plus 4. Alright, so we can draw the box there. X plus 4, right? This has two terms, this has two terms, so our box is going to be a 2 by 2 box. So we've got x times x squared, x times 4, 4x, x times 4, that's 4x, and 4 times 4 is 16. Don't write 8. We multiply. 4 times 4 is 16. Combine like terms, and this becomes x squared plus 8x plus 16. So you can see that she forgot the 8x. She just wrote x squared plus 16, and she was missing this middle term. So let's rewrite this step here as x squared plus 8x plus 16 minus 2x minus 5 equals... We got to fix the other side too. Well, let's see what we can do here. We can combine like terms. Combine like terms. So this is going to be x squared plus 6x plus 11 equals. Alright, and then I'll let you fix this side. So this is x minus 1 squared. Draw a box, figure it out, and then solve for x. So I hope you can see your mistake. She made that fake news mistake from class. She was missing the 8x term, and she'll be missing something on the right side as well. 5-15. Write the equation of each line described below. A line with a slope of -2 and a y-intercept of 0, 7. I'll let you do that. I'll do B. So a line with a slope of -3/2. Slope. So m equals -3/2. I'm referencing our master equation. Y equals mx plus b. Alright, now it gives us the x-intercept. So if you're picturing a little graph in your brain, 4, 0, our line is going to hit the graph at 4, 0, right there. But what's the starting value? They don't give it to us. So what do? We plug in the 3 values that they give us. They give us an x, which is 4, they give us a y, which is 0, and they give us an m, a slope, which is -3/2. So y is 0, m is -3/2, and x is 4. I'll put it in parentheses, plus b. So we plug in the 3 numbers, leave b, leave it alone. 0 equals, so to multiply these, I'll put the 4/1 and multiply straight across. 3 times 4 is 12, 2 times 1 is 2, negative times positive, negative. 12 divided by 2 is 6, so that's 0 equals -6 plus b. And if we add 6 to both sides, b equals 6, m equals -3/2. So let's write our equation. Y equals -3/2 x plus 6. Okay, part C is the same, but our slope is perpendicular, means opposite reciprocal. So if our slope over here, -3/2, to make it a perpendicular slope, you turn it upside down and you change the sign, negative to positive. Okay, so that's our slope. They give you a point, that's an x coordinate and a y coordinate. So take your equation, plug in 3, leave b, write that equation. 522. We have 2 equations, I'll solve b. I see the distributive property here. When you have parentheses and a number outside the parentheses, you distribute that number, in both cases, distribute that number. So here's how to do it. You multiply. 2 times x is 2x, then we have a plus sign. 2 times 1, that's 2. And then keep going from left to right, we have a plus 3 next. Then we have an equal sign, then we distribute again. 3 times x, that's 3x, minus 3 times 1, 3. Don't forget to combine like terms. This is 2x plus 5 equals 3x minus 3. We have x on both sides of the equal sign. We choose the smaller x, and we make it cancel. Move it over. Take away 2x. We have 5 equals x minus 3, and we are almost done. Make x alone. Add 3 to each side. X equals 5 plus 3, so x equals 8. Calculate the slope of the lines through these 2 points. Write the equation. Is this point on the line? So let's do this part and part A. So unless you're an expert, I recommend labeling these x1, y1, x2, y2. Then we plug it into our handy dandy slope formula. So y2 is -4 minus y1, which is -8. x2 is 3. Subtract x1, which is 6. So this is negative 4 plus 8. We have a double negative, don't miss that. And it's over 3 minus 6, which is negative 3. Negative 4 plus 8 is positive 4. That's positive 4 over negative 3. Whoops. And that is our slope. Alright, so I need to make some space. Here's where we're at. M equals negative 4 over 3. Now I had 4 over negative 3, but I had a positive divided by a negative. The whole thing is negative, so I move the negative sign out front. No problem with that. You're allowed to do that. Alright, and next we need to pick a point and make an equation. This is M, this is a x coordinate, this is a y coordinate, and our equation for a line is y equals mx plus b. So what do? We plug in 3, leave b. Y is negative 4 equals negative 4 over 3 times x plus b. Okay, put the whole number over 1 and multiply. Negative 4 equals negative 4 times 3, negative 12. Negative times positive is a negative. Over 3 times 1 plus b. Alright, negative 4 equals, so we have negative 12 divided by positive 3. Outcome is negative 4. Right, and then if you add 4 to each side, these cancel, that cancels. It's not no solution. Negative 4 plus 4 is 0. So b is 0. M is negative 4/3. So our equation is y equals negative 4 over 3x plus 0. Now because I'm adding 0, I'm allowed to just not write anything. That plus 0 is kind of invisible, so I can also write that. Okay, the rule, Miss Kai's class is studying a tile pattern. The rule for this tile pattern is y equals 10x minus 18. Khalil thinks that figure 12 of this pattern will have 108 tiles. Is he correct? Justify. Recall that x equals figure number and y equals number of tiles. So this is our equation here. And he thinks that figure 12 will have 108 tiles. So this is our x. So let's plug in x equals 12. And let's see if y becomes, what do we want? 108. So if we plug in 12 and y becomes 108, then yeah, he was right. So I'll let you try that one. That's not too bad. Just plug in 12, make sure y matches. And if not, he was wrong. 5-35. Deshauna and her team gathered data for their ball and recorded it in the table shown at the right. What is the rebound ratio? Recall that the rebound ratio is the rebound height divided by drop height. Okay, so the rebound ratio for us, and you can pick any two of these, the answer will be roughly the same. So let's get our calculator open. And let's try dividing. 124 divided by 150. 0.826666. So let's say 124 divided by 150 is equal to 0.83. Alright, I rounded up. 0.26, this number is 6, so that this number right here rounds up to 3. Now if you picked another random entry such as 92 and 110, if you divide rebound height 92 divided by drop height 110, you get about the same thing. That's okay. So I'll write here, answers may vary a little bit. but they should be around this number. Okay, so what do we do with that number? Part B. Predict how high Deshauna's ball will rebound if it is dropped from 275 centimeters. Okay, so the rebound ratio is equal to the rebound height divided by the drop height. Alright, we know what the rebound ratio is. It's 0.83. So we can replace that with 0.83. They give us a drop height, so we know what the drop height is. We can erase the drop height and replace it with 275. So now we have a little equation here. We want the rebound height, and I'm just going to call that h. So what do we do? Well, this is a fraction buster. Look at the denominator of the fraction, and we multiply both sides by that number. So we get 0.83 times 275. .83 times 275, and that's 228.25. That's I guess I'll write it down here for now, 228.25, and that's equal to h times 275, that's 275h, and it's still over 275. Now 275 divided by itself, that's the giant 1, so h equals 228.25 centimeters, and that's the power of the rebound ratio. We can predict these numbers. So if this were in our table, you can imagine another entry here. Let's see, drop height is 275 centimeters, rebound height is 228.25 centimeters. Okay, now suppose the ball is dropped and you notice the rebound height is 60. So what if the rebound height is 60 centimeters? What should be on the right hand side if this were like another entry in our table? So rebound ratio is rebound height over drop height. We can replace the rebound ratio with 0.83 because we know what it is. And we can also replace the rebound height with, 60 centimeters is the rebound height. So we're trying to find the drop height. Alright, so 60 divided by what is 0.83? Let's call this x. Same as last time. We can multiply everything by x, whatever's in the denominator, multiply by that. So we have 0.83x equals 60x over x. 60 times x is 60x, still divided by x. Alright. So we have 0.83x equals 60, because x divided by x is just 60. And divide both sides by 0.83. And x equals 60 divided by 0.83. .72.3. Okay, so that is 72.3 centimeters. It says use appropriate precision. You can see that none of these have decimals in them. So I think what they want you to do is round this to the nearest whole number. Like you would just round down to 72 here. This one you would just round down to 228. just to match what they have in the table. It doesn't matter too much. Use an appropriate precision. Since these are all whole numbers, you just round and make those a whole number. Wednesday homework. Look back at the data given in problem 5-18. Alright, let's get that data. Okay, so here's the tennis ball rebound ratio. So to get our rebound ratio, we take the rebound height and divide it by the drop height. So that's going to be 111 centimeters divided by 200 centimeters. And we'll use our calculator. .555. Well, let's round that to 0.56. Okay, so if we start with a height of 10 feet, here's my table. I've got drop height in feet and rebound height also in feet. So suppose you drop a tennis ball from an initial height of 10 feet. Well, to get the rebound height, you take 10 and you multiply it by the rebound ratio. Alright, so this is the rebound ratio. I'll move that off to the side a little bit. Okay, so how high would it rebound after the first bounce? 5.6 feet. So now it's 5.6 feet in the air. Let's say it goes down again. And I put feet in the table. I don't need to put it there. So now we're at 5.6 feet in the air. It goes back down. To get the rebound height, take what it's at and you multiply it by rebound ratio, 0.56. Let's round to 2 decimals, 3.14. So 5.60 feet, 3.14 feet. Now to get the third bounce, so we start at 3.14 feet in the air, that's where we're at, and it goes down again. Keep multiplying by the rebound ratio and see what comes next. So see if you can figure out how high it would rebound after the 5th bounce. Just keep following the pattern down until you get to bounce number 5. Alright, write an equation for the line containing the points in the table. First thing we need to do is find the slope, and then we'll put it into our equation y equals mx plus b. So let's pick a point, 3, 4. Pick a second point, 5, 10, and let's label it. This is x1, y1, our first point, and this is x2, y2, our second point. Alright, to calculate the slope, plug points into this formula. y2 minus y1, so y2 is 10, 10 minus 4, that's our y1, over x2 minus x1, that's going to be 5 minus 3. So 10 minus 4 is 6, 5 minus 3 is 2, 6 divided by 2 is 3. So our slope, m equals 3. Pick a point such as 3, 4, that seems like a good one. 3 is our x coordinate, 4 is our y coordinate. Now plug in 3, solve for b. Alright, solve each equation. We've got 2. Start with a. Okay, I see a fraction. So what do? Multiply both sides by the bottom of the fraction, 10. So we do 10 times 2x minus 8 all over 10 equals 10 times 6, which is 60. So we multiply 2x minus 8 times 10, and then we divide it by 10. We multiply by 10, then we divide it by 10. 10 divided by 10 is 1. It's the giant 1. That just cancels. And we're left with 2x minus 8 equals 60. Let's add 8 to each side. 2x equals 68. Divide both sides by 2. X is 34. Okay. Check your textbook. Refer to the sequences C and I of problem 542. Our sequences. Now if you remember, these sequences are not part of the arithmetic family. They are not part of the geometric family. So both C and I are neither. Are the part of the neither family. And maybe we should clean this up a little bit. Both C and I are part of the neither family. They're not arithmetic, they're not geometric, they're in the neither category. Alright, try B. Next is 546. Chelsea dropped a bouncy ball off the roof while Neary recorded its rebound height. The table at right shows their data. To what family does the function belong? Explain how you know. Well, if you remember, the rebound height is part of the exponential family. This is also known as the geometric family. And let's explain how we know. So let's take any of these two numbers and divide them together. Let's say 290 and 475. So we get this number, 0.61. Alright, so what we're going to do is take 475 and multiply by 0.61. If we round up, that's 290. And if we multiply by 0.61 again, let's do 290 times 0.61. We get 176.9. Alright. Which is pretty much what we have here, approximately. And if we multiply by 0.61 again, it brings us down to 100. Now because we rounded, we lost some accuracy. But pretty much, how do we know? This grows by multiplication. Not addition. If it grows by multiplication, then it's part of the exponential family, which is also known as the geometric family. Alright, let's check 548. First, let's find the slope, then we'll get the equation. Okay, here's our points. Our first point we'll call x1, y1, and our second point we'll call x2, y2. Alright, so to find the slope, you put it into this equation. That's going to be y2 minus y1. That is negative 11 minus 1. y1 is 1. x2 is 2, so that's 2 minus negative 2. So be careful with the negatives here. We have negative 11 subtract 1. It's negative 12 over negative 2 minus negative 2. When you subtract a negative number, it's the same as addition. Double negative makes plus. So that's negative 12 over 4. Answer negative 3. So you have your equation, you have your slope. Pick a point, like negative 2, 1. Negative 2 is your x-coordinate, 1 is your y-coordinate, here's your m. Plug in 3, leave the b, b. Find the equation.